Hello, my name is Scott Sabol. I am a structural engineer, which I'll explain what that is, and I'm also a college professor at Vermont Technical College. Today I want to tell you a little bit about both of those careers, what it means to be a structural engineer, and what it means to be a college professor, to give you a better understanding of that. I started by going to college and studying engineering, and then I worked as a structural engineer right out of college. I worked for about a decade, and then I decided I'd also become a college professor, and I would teach the stuff that I was doing as a structural engineer. So with that, I want to show you some information about being a structural engineer and a college professor and some of the projects that you would get involved with and the type of work you would do on a daily basis. So as I said, my name is Scott Sabol, and I'm something called a professional engineer, PE. That just means that I have passed the appropriate tests and gotten enough experience so that the state thinks I can safely design buildings that the public might interact with. And I'm in the Architectural and Building Engineering Technology Department at Vermont Technical College. So, what is a structural engineer? Well, we design and help make buildings, bridges, and other structures so that they remain standing. When the winds blow or an earthquake occurs or the snow falls, we want our things to stand up. We design the layout of the frame. So the frame is the beams and the columns and their arrangement. And we pick the materials from which we're going to build those: steel, aluminum, concrete, wood, fiber reinforced plastic. Typically, a structural engineer majors in civil engineering or architectural engineering in college. And in general, we know an awful lot about materials and physics and mathematics. They're often licensed as professional engineers, but you don't have to be licensed to work as an engineer. There are simply restrictions on what you can and cannot do if you are unlicensed. I want to take a minute to explain the difference between architects and structural engineers. So here's a very famous building in New York, and someone had to come up with what it looks like, how the floors are laid out as far as the rooms, where the elevators should go, what the outside looks like as far as a reflective surface. Well, that is, excuse me, the role of the architect. In this case, a person named Mies van der Rohe. But somebody else had to figure out, how do I make this thing stand up? Do I make it out of steel or concrete? How big are the earthquake loads that are going to make it sway back and forth going to be? And the wind loads? And how much are the people loads inside? That's a structural engineer. Fred Severud is the engineer who designed this. So there's always multiple people involved in buildings, each with a different role. So what are the activities of a structural engineer? Well, we design new buildings and bridges, and I'll talk about what I might do on a daily basis in a minute. Or we see if an existing building can perform a new task. What if there was an old store, a retail store in your town, and they wanted to convert it to a library? Well, when it was a store, it had clothes maybe, and when it's a library, it's going to have heavy books. So is the floor system strong enough? We might have to check that out. A structural engineer might get involved when evaluating a structure after a calamity, an earthquake, a tornado, an explosion. We might be asked to go in and investigate, is the building safe to enter? Or what parts are damaged? Do they have to be repaired, or does the whole building have to be demolished? And what's really neat is there are some special structures that structural engineers might get involved with. Offshore oil platforms. We have to be able to hold up all that equipment. The space station has forces exerted through centripetal or centrifugal action as it circles the Earth, and through the dynamics, meaning the other accelerations that occur. And things like cranes, big crane booms carry big loads, and often structural engineers work in the manufacturing companies that do cranes. Or amusement parks. Structural engineers are involved in the design of roller coasters, for example, because we have to carry the loads of the people safely. Kinds of things I need to figure out when I do my designs. Well, if it's a building, I have to figure out, how heavy is the snow going to be? Because if the snow is going to be very heavy, then I need a stronger roof system with maybe 2x12s instead of 2x10s for my rafters. I have to decide how much pressure the wind will cause so the building doesn't fall over. We have to know what the people will weigh. Because think about your house versus a theater. Your house is not going to be full with people every couple of feet, but a theater might, so the loading in a theater might be higher. We have to figure out how much the structure moves as it reacts to the loads. Does it go up and down, left or right, or rotate? We need to pick materials that will be durable enough to last a long time, and we have to build with sustainable materials because it takes energy to produce steel and concrete. And when we use wood, wood is good for a while, but when it is used up and the building is torn down, that wood might start to rot and that releases carbon dioxide into the air. So we have to think about those sorts of things. Now, some examples of what a structural engineer might do. So you might do something for one entire day or an entire week, or you might mix these things up in a single day. So these are bridges in the Florida Keys carrying traffic. And so a structural engineer might design these, or in my case, it was known that these were corroding. Reinforced concrete bridges have steel inside of them. And the ocean has salt water, and salt water makes steel corrode. So we wanted to measure how much it was corroding. So there's a picture of a young version of me, and I'm holding in my hand a device that actually measures the corrosion rate. It can say how fast the steel is corroding, because it turns out when steel rusts, it creates an electrical current and a voltage, and we can measure that and turn that into how much it is actually corroding. That is why I said that engineers need to know something about science. We might, on a day or for several days, observe a project that we designed or were involved with being built so we can make sure it's being built correctly. We don't build it. The construction companies build it, but we sort of watch and make sure everything looks right. So here I am standing in front of a bridge pier in Pennsylvania, and notice I'm standing on dry ground. So I would observe the concrete being placed into that steel formwork, and that's going to hold the concrete until it's set and cured and able to carry load itself. Well, here's that very same bridge, and there's that very same pier right in the middle. Ooh, water flowing. In that previous picture, we actually diverted the water around the pier, the central pier, so it could be built. And then the diversion was removed and the water flowed freely, and there's a concrete pier. Well, some of the time in the office, we're doing calculations, and the calculations might be on a computer using a computer program. So you can see this looks like something you might punch numbers into, and a computer program kind of does the math. And we sometimes will spend our time actually doing the calculations by hand using a calculator. There's still a lot of hand calculations that are done in engineering. And so we need to make sure we do things accurately. A lot of trigonometry, geometry, and algebra, which are topics you typically learn in high school and more in college, plus some others. But we need to figure out, in this case, I was trying to figure out the capacity of a certain piece of wood, which had dimensions of 1 3/4 inches by 14 inches. It was something called an LVL. And I wanted to know, based on other information, how much load it could carry in pounds per square foot. So we have to be able to do the calculations, know what calculations need to be done, and present it in an orderly fashion. Here is a wood-framed building. And again, we might have designed the roof rafters and the stud walls, or we might be watching the construction, or we might be answering questions by the builder who's trying to interpret our plans where we laid out in a drawing where all the pieces of wood should go. Maybe there's a difficulty in understanding exactly what that layout was supposed to be. Here's an old church. This is in Brookfield, Vermont. I was asked to take a look at it and see if it seemed structurally sound. So I looked at the walls and determined if they were very plumb and straight and flat. I looked to see if there was water damage because it was an old slate roof. I could have looked at the actual structural elements. I didn't do that in this case. I looked at the foundation around the bottom, and it was a stone foundation, and tried to determine whether it looked reasonable or whether maybe there were bends in it or it was bowing out. And in this case, I walked inside and I saw a big crack. And one of the things that engineers, who are structural engineers, do is we look at what might be a problem and determine whether it is a problem. Because some cracks aren't problems and some cracks are big problems. And so in this case, sometimes we just have to figure out, was this something that happened one time under a huge windstorm? It cracked once, the wall cracked, and it never cracked anymore? Or is it growing and it might cause a problem in the future? So we use engineering judgment. We might be involved in a fancy restaurant design. This is in Las Vegas, and I said I'm a college professor. One of my students graduated, and he helped design this. Well, it takes an architect to lay out the look of it, but it takes a structural engineer to make sure it can hold up the load of this restaurant that's right in the middle. Here's a roof system in a house. So a structural engineer can figure out whether these roof trusses can carry the snow load, or whether it needs to be strengthened, or whether there's problems. Maybe you see your roof seems to be bowing. Is there damage in any of the members? And we might be involved in the power industry because a structural engineer can determine the loads on a power transmission pole. And we might also work for the company that manufactures the transmission pole. We don't worry about the electricity. That's an electrical engineer's job, but we make sure all the weights and loads get down into the foundation. And again, there are failures that occur. And here's a wind turbine, and we might be called in as structural engineers to determine, hey, why did that fail? Was there a problem here at the base? Was it not designed for the appropriate load? Was there a manufacturing defect or something else that caused the failure? So that's what I do as a structural engineer, all those kinds of things. Some might take a whole day, or it might be a mix of those during the week. But then I said I also became an engineering college professor, and I want to tell you a little bit about what that's about. So what do we have in common when we are professors? Well, we typically enjoy teaching others about stuff that we know very well. And so when I was an engineer, people often said to me, I explain things well. So that made sense that, hey, maybe I should become someone who teaches it in addition to doing it. We typically went through a lot of school. So typically to become an engineer, you get a bachelor's degree at least, or maybe a master's degree, something called graduate school. But a lot of college professors get what's called the terminal or highest degree, which is a doctorate degree. Not a medical doctor. It's a doctor of engineering or a doctor of philosophy in engineering. A typical day when you're a college professor is preparing and teaching several classes. I might be teaching students how to design things out of wood, or I might be teaching students how to design a foundation for a building, or I might be teaching them how to analyze a complex system of forces. I'm grading assignments like homework or exams, and I'm doing whatever else is necessary to help the students to learn, which might be one-on-one help sessions if they're having challenges with the material. College professors are often seen as experts because of our formal schooling and typically a lot of experience. And we often create new ways to design objects or solve problems. And that's a really fun part of the job. So that is a little bit about what a structural engineer is and does and what a college professor does. And if you like what I do, if you're somebody who likes to see your final work out there for everybody to see, you might want to be a structural engineer. What you should do is continue in school and study math and science and English, because I didn't talk about that, but we write a lot and communicate a lot. And so that would put you on the path to becoming a structural engineer. And when you drive around and see buildings and bridges, look at them. Think, I wonder how that works. And if you can think about that, you might enjoy as a career what I enjoy as a career. Thank you.